as we've seen, graphs of exponential functions, like I said before, you have to make your own table for these, okay? Which means that you're going to have to be choosing your own values of x. They're not even going to give you the table, all right? So you got to make your own table. Now, like I said, on Canvas, you're going to need 2 ordered pairs. That's it. That's all you're going to need, okay? But if I remember right, Canvas won't accept fractional values. So if you end up with fractional values, you have to keep going until you get non-fractional values. And we talked about how to do that, especially when the exponent itself is negative. Okay, so we're going to graph the points, and then it's going to create, because I'm going to be doing more than 2 points on these graphs, but it's going to create a pattern, and then the pattern continues. The patterns, of course, they are patterns. It's just that they're not as convenient as y equals mx plus b linear equation type patterns, okay? This is just, I don't know, just some interesting facts, I guess, about this. But if your base is greater than 0, then it's called next. The base has to be greater. This is what that base has to be. Now the graph is going to look like this if the base is greater than 1. Okay, and as long as there's nothing else with the x or being added or subtracted to the base b, you should have the y-intercept always at 0, 1. Again, that's only if there's nothing being added or subtracted to the x's, whether it's in the numerator or the exponent or not, okay? If the base is, because we can't have negative bases, if the base is between 0 and 1, then it's some kind of fractional decimal value, then it's going to look more like this. You don't have to memorize this stuff because it's all going to take care of itself when we start making our tables. But just keep in mind, this is kind of the foundation of what our graphs should look like in the end, which is why on the computer it knows that the graph should look like this. And so when you put 2 points on there, it just knows what to do. Okay, then we got the domain and range. There's no x-intercept. Oh yeah, why is there no x-intercept? Because no matter what the base is, again, we can't have negative bases, but no matter what the base is, you can't get a value that's ever equal to 0. You could get something really close to 0, and it could be infinitesimally small. I don't know, I feel nerdy saying that, but you can never actually reach 0. Even if the lines look like they touch, they're not, if you were to zoom in far enough. All right, so here's our first equation for us. Now notice, this line is blue, just, I don't know why it is, and it's even got these 2 dots. Ignore that crap, okay? But we notice that this one goes all the way up to 20. That's good. Okay, so once again, we got to pretty much create our own table of values here. We got x's and y values. I put 5 values in this, right? 1, 2, 3, 4, 1, 2, 3, 4, 5 values. I can fit 5 values in my table. If I need more, then I would just expand the table. We'll see if we do, all right? It's just that our function is 3 to the power of x. Now, when you look at values of x to choose, you can choose negatives, you can choose positives. I always recommend choosing at least 1 negative. I'm going to go with 2 negatives on this one, though, okay? And it should kind of confirm the pattern for us. These are going to give us fractional values. I don't care about these fractional values because I just want you to see what is happening in the graph. A very convenient value to use is 0. Okay, especially when there's nothing being added or subtracted to my x exponent, okay? And then, of course, I'm just going to go the other direction with 1 and 2. We'll see if this fits. In fact, yeah, this is going to fit. I couldn't go up to an x value that's 3 because 3 to the power of 3 is 27, and that's not going to fit on this graph anyway, so I'm going to ignore that, okay? Let's go ahead and find our first y value where x is negative 2, okay? So I'll give myself a little space here. We'll say f of, now it's negative 2, right? So that'd be 3 to the power of negative 2. You're welcome to put that into the calculator. We've already solved that one, but it's still 1/9, which is, I do need the decimal on this one just because I'm going to put it on the graph. It's 0.1 repeating. I put 2 ones, but whatever. So let's see if I can fit this on there. Okay, negative 2 and 0.1. Again, even the hundredths right there would be very difficult to graph. That red dot, not this one or the other square one, this one right here. Okay, so that's negative 2 and approximately 0.1. Now again, you wouldn't do this on Canvas because, like I said, I don't think it's going to accept the partial values, the decimals or fractions. Okay, But again, I want us to be able to see this. So in my table, by the way, I probably should put that in there. That gave us 0.11 there as well. Well, 0.1. Because again, I couldn't really fit that hundredths in there. Well, what about -1? Well, let's do this one in purple. Okay, so that's f of -1, right? So that'd be 3 to the power of -1. We've seen that already as 1/3, which is approximately 0.3. Okay. Now, I know the 3 repeats, but I don't really care about that because I can't fit hundredths on my graph anyways. So I'm just going to use 0.3. Where is that on my graph? -1 and 0.3. It's still less than half, you know, somewhere in this range. Right there for my purple point. Now you can see that it's starting to increase, which is good. We should see some increasing going on because our base is more than 1. Okay. Next up, now the x is going to be 1 on this one, 0 rather. Sorry, and I'll do this one in green. So we're looking for f of 0. I've chosen the x to be 0, so that's 3 to the power of 0. Anything to the power of 0 is 1. That's easy enough to graph. 0, 1. That's our ordered pair. 0, 1. That's our y-intercept. Okay, that's the green ordered pair. Let's go to the next one. These are getting easier, you see, and there's a reason for that. It'll take some experience to really get used to it, though. But now I'm looking for f of 1. That's 3 to the power of 1, which is just 3. So I get the ordered pair 1, 3, which would be right here. Now, just from this pattern, you can see that it's curving upwards, right? It's going up pretty fast. And towards the left, it's getting very, very, very close to 0. But again, you can never actually reach 0 on the x-axis right here, okay? Now, let's try that last one. We got f of 2, right? Do this one in blue. It's f of 2, which makes it 3 to the power of 2, which is 3 times 3 is 9. So that's 2, 9, and we can fit this one on the graph. 2, 9 would be right here. Now, the next one would have been 327 way up here, way up there, okay? Sorry, way up there. But this is good enough. And like I said, on Canvas, really you should only need these 2 points. If you wanted to do these two, it would still understand, okay? So they don't have to be right next to each other, just any 2 points. Again, you wouldn't be able to use on Canvas these fractional values, but you can see it's easier just when you used positive values for your x's. So why did these come out as decimals? We talked about this already, but it's because the negative exponent reciprocates that, which would have made this 1 over 3 to the power of 2, which is 1 over 9, okay? So if you force the exponent to be a negative, then you get those fractional values. Now again, I did this because, well, it's nice, you know, to be able to see these and how they work. Let's see what the graph would look like approximately. I'll try not to mess this up too bad. Now, I'm going to make that line. I'm just going to show that it goes forever to the left here, getting ever closer to 0. But I just put an arrow there at the end. When I do this, I also start with just the y-intercept. I don't know why I do that, but I kind of split it in half, so I got a couple different tasks to do. But see if I can do this next one. I can do better than that. I think I could do better than that, but I don't know that I'm going to get much better. Sorry. But Canvas knows how to do that much better than I just did. Okay. But that's what our line looks like. And again, this would keep going upwards like this, in this direction that way. Okay. So, well, that made it more sloppy, but hopefully that kind of makes sense.